Hello and welcome to Algebra 1, Lesson 24. In this video, we're going to learn about applications of a linear systems. So we previously learned how to set up and solve a word problem that involves a linear equation in one variable. Here we will apply a similar process to solve problems that involve a linear system in two variables. All right, so let's quickly cover this procedure, and it's just a modified version of the original one I gave you. So solving a word problem that involves a linear system in two variables. So obviously the first thing you want to do is read the problem carefully, get a clear understanding of the objective. Then we want to assign a variable to represent each unknown. And because we're working with linear systems in two variables, we're going to write two equations using both variables. Then we want to solve the linear system. We're going to state the answer. And generally speaking, when we're working with word problems, we want to make a nice little sentence. And then lastly, we're going to check. And remember, with word problems, we want to make sure that the answer is reasonable. If you had a question like how many cars were produced at a factory and you get negative 37.2, it's probably not the right answer, right? The factory would produce either 0 or some positive integer amount. All right, let's go ahead and take a look at the first problem. We have enough experience with word problems to just kind of jump right in. So Kayla and Kristen are selling wrapping paper for a school fundraiser. Customers can buy rolls of plain wrapping paper and rolls of holiday wrapping paper. So Kayla sold 6 rolls of plain wrapping paper and 5 rolls of holiday wrapping paper for a total of $149. Kristen sold 6 rolls of plain wrapping paper and 2 rolls of holiday wrapping paper for a total of $92. So we want to find the cost of 1 roll of plain wrapping paper and 1 roll of holiday wrapping paper. So remember, our first step was to read the problem and get a clear understanding of the objective. Well, the objective is right here. We want to find the cost of 1 roll of plain wrapping paper and 1 roll of holiday wrapping paper. So I should be able to make a nice little sentence in the end that says the cost of 1 roll of plain wrapping paper is this much, and the cost of 1 roll of holiday wrapping paper is this much. All right, so for the next step, we want to assign a variable to represent each unknown. We don't know how much is 1 roll of holiday wrapping paper. I'm just going to put W period P period. That's for wrapping paper. And then we also don't know how much is 1 roll of plain wrapping paper. So plain and then W period P period, just to abbreviate a little bit. So let's assign a variable to each one. And let's just use X and Y because those are the most common. So let's let X equal the cost, or you could say sale price, of 1 roll of plain wrapping paper. So I'm going to put WP for that. And I'm going to put some periods there just for abbreviation. W period, P period for wrapping paper. So then, for our other unknown, I'm going to say Y is equal to the cost of 1 roll of holiday wrapping paper. So again, W period, P period. And don't get confused here. When I say cost, I mean sale price. So a lot of students will see that and say, well, is that the cost that they pay? And it's a little confusing. So I want to just clarify and say that the cost here, when we say that, we're saying the sale price, or in other words, the cost for the customer, the person who's buying it. All right, so for step 3, we want to write 2 equations using both variables. So in order to do that, we need to read back through the problem. So I'm going to go to this part where all the information is given. So reading back through here, we see that Kayla sold 6 rolls of plain wrapping paper and 5 rolls of holiday wrapping paper for a total of $149. So we can use this information to make our first equation. So 6 rolls of plain wrapping paper, 5 rolls of holiday wrapping paper, again, for a total of $149. So putting that into an equation, just using our variables for the unknowns, we would have 6 times X, right? X is the cost of 1 single roll of plain wrapping paper, plus 5 times Y. y is the cost of one roll of holiday wrapping paper, should be 149, the total cost when these two are added together. So again, this is going to be 6x plus 5y is equal to 149. And let's label this so we don't get confused. So 6 represents the number of rolls sold. And so does 5. So let me draw a little arrow over to 5. For x, this is the cost of one roll of plain wrapping paper. So the cost of one roll of plain wrapping, let me kind of get rid of this, paper. Then for y, it's the cost of one roll of holiday wrapping paper. So again, 149 is the total money she brings in. So I can put the total from the sale of both. So she sells 6 rolls of plain wrapping paper. So that's modeled with 6, the number of rolls sold, times x, which is the cost per roll, again, of plain wrapping paper. Then we add this to 5, which again is the number of rolls sold, times y, which is the cost of one roll of holiday wrapping paper. So we sum these two amounts together, and we get the total amount that she gets from the sale of both. That's 149. So there's your first equation. Now for the second one, let's read about Kristen. So Kristen sold 6 rolls of plain wrapping paper and 2 rolls of holiday wrapping paper for a total of $92. I can go through and highlight that. So 6 rolls of plain wrapping paper, 2 rolls of holiday wrapping paper. Again, this is for $92. So we're going to come down here and just make a similar equation. So we'd have 6 times x plus 2 times y is equal to 92. And if we went through and labeled it, it would be the same, right? You'd have 6, which is the number of rolls sold, times x, which is the cost of a single roll of plain wrapping paper, plus, and then you'd have 2, which again is the number of rolls sold, times y, which is the cost of one roll of holiday wrapping paper. And the sum here is going to equal 92, right? That's the total from the sale of both. All right, so we've correctly modeled each situation for the two girls. So let's look at these two equations now and see if we can solve this linear system. So I'm going to rewrite them down here. So I have 6x plus 5y equals 149. And then I also have 6x plus 2y equals 92. Now, it'll probably be easiest to use elimination here. Now, none of my variables would drop out if I just went through and started adding. What I need to do is make a slight modification. You can see that the coefficient of x is 6 here and 6 here. So if I multiplied one of these equations, both sides by -1, one of these would turn into -6 and one would be +6. And so when we did our addition, the x variable would drop out. So I'm going to multiply this second equation here by -1. And so I would have 6x plus 5y equals 149. Still for my first equation. For my second equation, -1 times 6x is -6x. Then -1 times 2y is -2y. And this equals -1 times 92. That's -92. All right, so let's add the two left sides together. So I'm going to do this vertically. So 6x plus -6x is 0. So that's been eliminated. 5y minus 2y is 3y. And this equals, now we're going to sum the right sides. 149 plus -92 is 57. So as a final step, we divide both sides of the equation by 3. And we get that y is equal to 19. So once you have this, you're not done. You need to figure out a value for x. And we look at our two original equations. Again, y is equal to 19. I can plug a 19 in for y in either equation. Looks like it'll be a little bit easier here. So I'd have 6x plus 2 times 19 is equal to 92. So then this is 6x plus 2 times 19 is 38. So 38 equals 92. Subtract 38 away from each side of the equation. That's going to cancel. I'll have 6x is equal to 92 minus 38 is 54. And then we divide both sides of the equation by 6, and we get that x is equal to 9. So this is the ordered pair, 9, 19. And just for the sake of completeness, I like to go through and check, make sure that that ordered pair works as a solution to both equations. And then we go back up and then we state our answer. So 9 is my value for x, so 6 times 9, plus 5 times 19 is my value for y, and this should equal 149. 6 times 9 is 54, plus 5 times 19 is 95, so this should equal 149, and it does. You get 149 equals 149, so we're good to go here. Let's look at the second equation. All right, for the second one, we're going to, again, plug in a 9 for x, so we'd have 6 times 9, plus 2 times for y, we're plugging in a 19, and this should equal 92. 6 times 9, again, is 54, plus 2 times 19, that's 38. This should equal 92. And 54 plus 38 is 92. So you get 92 equals 92. So yeah, checks out here as well. Now remember, with a word problem, you've got to make sense of everything. You can't just stop and say, my answer is the ordered pair 9, 19. That doesn't relate to what you got. Your teacher would only probably give you partial credit for that. So let's go back up to where we wrote what the variables were representing. So remember, x was the cost, or again, the sale price of one roll of plain wrapping paper. And we found that x was equal to 9. So x was equal to 9. So then one roll of plain wrapping paper is $9. Then y is the cost of one roll of holiday wrapping paper. We found that y was $19. So to answer this, we can say that each roll of plain wrapping paper, which again I'll abbreviate, sells for $9, while each roll of holiday wrapping paper sells for $19. And although we've checked the equations, go back into your actual problem and make sure that that makes sense. So again, Kayla sold 6 rolls of plain wrapping paper and 5 rolls of holiday wrapping paper for a total of $149. So you're checking this just like you checked your equation. It's basically the same thing. So 6 rolls of plain wrapping paper, again, each roll is $9, so that would be $54. And 5 rolls of holiday wrapping paper, again, each roll is $19. 5 times 19 is 95. So you sum these two amounts together, you would get a total of $149. So that part's good to go. Then again, the second part, Kristen sold 6 rolls of plain wrapping paper. 6 times, again, 9 is 54. So that's $54. 2 rolls of holiday wrapping paper, 2 times 19, right? $19 a piece for the holiday wrapping paper. That's $38. Sum these two amounts together, and you would, in fact, get $92. So our answer here is correct. Each roll of plain wrapping paper sells for $9, and each roll of holiday wrapping paper is going to sell for $19. All right, let's take a look at another one. So a plane traveled 700 miles to far land and back. The trip there was with the wind and took only 7 hours. The trip back was into the wind and took 14 hours. Find the speed of the plane in still air and the speed of the wind. So when you get these type of problems, you're always thinking about, okay, although it might not be 100% accurate in real life, if you're going with the wind is pushing on the back of the plane, or a lot of times you'll see these with a kind of a current problem where the current is pushing the boat. So you have a current or you have a wind that's pushing at your back that's making you go faster. When you fly into the wind, or when you are in a boat and you go against the current, you're fighting it, so you're going slower. So the main thing you're trying to figure out here, your main objective is to find the speed of the plane in still air, so meaning the air is not moving at all, and the speed of the wind. So the speed of the wind. So we're going to use 2 variables to represent each, right? Those are our 2 unknowns. So let's let x equal the speed of the plane in still air And then y can be the speed of the wind. Now, again, for this type of problem, because it involves motion, we're going to be using our distance formula. So you should remember this from when we were solving word problems with linear equations of one variable. The distance formula looks like this. You have your distance is equal to the rate of speed multiplied by the amount of time traveled. And again, this is very, very intuitive. You jump in a car, you go 70 miles per hour for 4 hours. Forget about the units, just multiply the numbers together. 70 times 4 is 280. So that would be 280. If you think about the units, it would be 280 miles. Very, very easy to calculate your distance if you know a rate and a time. Just multiply the two together. You could manipulate this in many ways. You could solve for rate and figure that out if you had the time and the distance. Or you could solve for time and figure that out if you had the rate and the distance, right? So on and so forth. But what we're going to do in this particular problem is set up a nice little table. So I have that distance is equal to rate times time. So I'm going to put this up top, draw a little line down here. All right, so we have two scenarios. We have the trip there. We have the trip there. And we have the trip back. Let me get a little bit more room. Let me kind of scoot this over. All right, so let me put this down here. Equals. So let's go in and get some information. So for the trip there, we know the distance is 700 miles in each case. So the trip there and the trip back, the plane traveled 700 miles to Farland and back. So the distances will be the same. So let's fill that out. So the trip there, the distance is 700. The trip back, the distance is also 700. Now, let's talk about the rate. The trip there was with the wind. So that means that whatever the plane would do in terms of its speed, you have to add to that the fact that the wind is pushing at your back. So you take the plane's speed in still air, which we represented with x, and you would add to that the speed of the wind, which we represented with y. So for your rate, for the trip there, it's going to be x plus y. Now in terms of time, it says it took only 7 hours. So we have a rate, we have a time, and we have a distance. So the time is 7. Now for the trip back, it says it was into the wind and it took 14 hours. So into the wind, that means that I'm taking the speed of the plane in still air, which is x, and I'm subtracting away the airspeed, or the speed of the wind. So that's minus y. And then the time is 14, right, for 14 hours. So then we'll have our two equations. Essentially, we have an equation for the trip there, which is a rate times a time. We have 7, which is our time, times our rate, which is x. Again, this is the speed of the plane in still air, plus y, which again is the speed of the wind, or the wind speed. And when we multiply these two together, we're going to get the distance, right? This is a time, this is a rate. Rate times time gives me a distance. So this should be equal to 700. Then for the trip back, I set up another equation. Again, I have a time, that's 14. And this is multiplied by the rate, which is x. Again, the speed of the plane in still air. Now I'm subtracting away the wind speed, because if I'm going against the wind, I'm fighting it. So I got to subtract that away. So then minus y, and this equals 700. So I have a time times a rate, or a rate times a time gives me a distance. Same thing up here. I have a time times a rate that gives me a distance. So I have two equations and two unknowns. So let's go ahead and just solve this system. So 7 times x is 7x, plus 7 times y, that's 7y, and this equals 700. And then I have 14 times x, that's 14x. And then minus 14 times y, that's 14y. And this also equals 700. Now, again, it would probably be pretty easy to use the elimination method, specifically because I have a negative here and a positive here. And all I need to do is multiply this top equation, both sides, by 2, and I would have opposite coefficients for my variable y. So let's go ahead and do that. If I multiply this side by 2 and this side by 2, I would have 14x plus 14y is equal to 1400. And I'm going to go ahead and erase this for now. And these are going to be the two equations I work with. So I'm going to use my elimination method. 14x plus 14x is 28x. When I add here negative 14y plus 14y, that's going to be eliminated. And then this equals 700 plus 1400, which is 2100 or 2100. So now to get x by itself, I divide both sides of the equation by 28. And that's going to give me that x is equal to 75. But again, I'm not done. I've got to find out the value for y. So let's go back and look at one of these original equations. Again, we found that x was equal to 75. So we had 7x plus 7y equals 700. And we had 14x minus 14y equals 700. So plug in a 75 for x in either one. So let's just take the first one. So 7 times 75 plus 7y equals 700. What's 7 times 75? That's going to be 525. So we'd have 525 plus 7y equals 700. And then we'd subtract 525 away from each side of the equation. That's going to cancel. And we'd have 7y is equal to 700 minus 525 is 175. Then if I divide both sides of the equation by 7, I'm going to end up with y is equal to 25. All right, so now we can write this as an ordered pair. We'll say it's 75, 25. And let's just check this guy in both equations. So we'd have 7 times 75 plus 7 times 25 equals 700. So 7 times 75 is 525. Plus 7 times 25, that's 175. This should equal 700, and it does. 525 plus 175 is 700. So these two sides are equal. So this one checks out. Then for the next one, we have 14 times 75 minus 14 times 25. And this should equal 700. So 14 times 75 is 1,050. Minus 14 times 25, which is 350. And this should equal 700. And again, it does. 1,050 minus 350 is 700. So you get 700 equals 700. So it works out there as well. All right, so remember, with a word problem, you always want to make a nice little sentence. So we're just going to say that the speed of the plane in still air was 75 miles per hour. And the wind speed was 25 miles per hour. And let's see if this just makes sense in terms of what the problem said. So a plane traveled 700 miles to Farland and back. The trip there was with the wind and took only 7 hours. So we know that if the plane was going 75 miles per hour and there was a 25 mile per hour wind, then each hour the plane is traveling 100 miles. So then it does this for 7 hours. It's going to get 700 miles worth of distance. So that checks out. Now the trip back was into the wind. So if it's going 75 miles per hour and the wind is 25 miles per hour, you subtract, you would get 50 miles per hour. And then it does that for 14 hours. Well, 50 times 14 is also 700. So that checks out as well. So again, the speed of the plane in still air is 75 miles per hour. And the wind speed is 25 miles per hour.